Here's a schematic design assignment that I expect people to complete. This can be done digitally or manually or however you wish to do it. It's pretty straightforward and very simple, I think. And we are going to visually put create a block representation to scale of the amount of space that we need. I'm looking at Connor's spatial summary, and I'm going to try to transpose what I'm reading here. Okay, and we're looking at 2,000 square feet. Can you guys read this? 2,000, yeah, square feet. And this is a greenhouse. You might want to work on graph paper to start. We have one of those. We have a viewing area. One of those at 500. Cafe, 1,000. Well, okay, we got. Let's add the quantity column here because, oops, we've got 5 cafes. Each of them is 1,000. So this is going to be 5,000. Let's just do a 5 each, right? 5 each at 1,000. Uh, I should have been looking at the left column. Silly me. Vendors, 12, 1250 total. What I care about totals are now vendor seating. We got 1,000. Research lab, office space, gift shop, restroom. I'm going to group those together, but I'm going to add up the quantity. So I'm not passing judgment on whether these are correct right now. I'm assuming you've done this correctly and we're translating this to this graphic representation that I want to create. So I'm adding up 1,500, 750, 1,000, and 1,500. Because that's similar use. So 4,750. We have let's call it office. If I'm wrong about this, we can correct it afterwards. And then Connor's put aside for circulation. Looks to be an intelligent number. 2,700. Right? What was that? 500. The viewing area. So coffee growth and viewing area. I may group these together. This 2,500. Decide on what a square wants to represent. If I take one of these squares and decide that each edge of it is 10 feet, that's 100 square feet. Right? So my greenhouse, let's start here and go that way, needs 20 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I may do something like that. Because that is a 10 by 2 area. There's my 2,000 square feet. Oops, sorry, 2,500. 1, 2, 3, 4, 5. 10, never mind that. So that gets, you can paint it a particular color, do whatever you want with it. This could be a straight line and it would go all the way out to one side. Quite clearly, we're not going to be able to do that. So we've done the 2,500, 5,000 square feet for viewing cafe. Let's go, that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 2,000. This would be 4,000. And then one more of these. Can we agree that this is 5,000 square feet? Right? How do I know that? I counted 20 squares this way. 20 and 20 is 40. 40 times 10 is 4,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5,000. Right? So we have a different pattern for each of these. We need 12. We got that. We need 1,250 for vendors. 10 is 1,000. 1,250 would be halfway in between. Vendors. The office is 4,750. That's almost as big as this thing, isn't it? How can we do that? If this is 5,000, we would need to remove 250. So we would remove 1, 2.5. So let's draw that one. And then take out 1, 2.5. We got to stop there. That's 4,750. Office. What does that include? That includes a lot of stuff here. Right? might say, Sandro, what the heck do you do? Why are you grouping all these things together? Well, because for the purposes of showing this, we made all this office, right? But the fact is that we're accounting for all the space that we're using. We have a graphic representation at a particular scale. Connor's using, have we finished? 4,750 vendors. Vendors was 1,250. Oh, seating. We need 1,000 for seating. That's seating. And circulation. Well, we know this is 2,000. To this is 2,000. One, two, three, four, five, six, seven. There's 700. Right? Are we in agreement there? This is circulation. I could take some colored pencils just to give it a. What's this 5,000? That's whatever. That's easy enough to do with a computer. Some color fill. Maybe you should have used it brown for a different. Okay. Now, so why am I doing this? Because this is a spatial representation of your program. This has to fit in the building. What's the size of the building? I asked for you guys. So one is your block drawings. This is one of the simplest versions of them. Then I asked for floor plans, the footprint, the building footprint. How can I determine that? I could do a couple things here. I could draw the actual building at scale here, or I could draw the overall dimensions if we're looking at a largely rectangular space, right? Um, let's pull up a copy of that building. Actually, you know what? Just to confound things, let's look at a different building that's largely rectangular and like 585 Commercial Street. I don't want to switch screens here. Well, let's do that. We'll pull up the Revit window. There's 585 Commercial Street, right? We have a Revit model. It's a little bare bones of a model, but that'll give us a. Let's look at the floor plan at level 1, right? So we have some dimensions here. I'm going to go from the outside to outside. 116 by 112. 116 by 112. Right? Does everybody see this? I'm drawing window within a window. So 116 by 112. And I want to draw it at scale here. So let's switch back to all right, it's playing picture within a picture. Hang in there, you guys. Don't panic. Uh, okay. I made a scribble notation of the size of that building. Right. Consider this: 116 in a sea of 10-foot squares. That would be 12 squares in one direction. Let's draw that with a different mark. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12. That's about oh sorry, 12, 13, 12 is 120. Right. So the 116 feet would be about there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm drawing is the footprint of the building. .585 commercial. Now, this program isn't going to fit in there, right? Does that make sense? What is the total of Connor's square footage? He's got 16,200. That adds up to 16,200. What is the area of, what is 112 by 116? That is 12,992 square feet. Right. So if Connor were to use 585 Commercial Street for this program, okay, even though we have gaps in here, right? Everybody keep in mind that we have not drawn into these areas. Think of it as a Tetris game, right? So these are not contiguous. They haven't been drawn out. But the rest of this represents the program. And we can see the difference between the 16,000 square feet and the 12,000, 13,000 square feet. It just doesn't fit on a single floor. Okay. Yes, we're not accounting for egress, stairs, and that kind of thing. But here, which was intelligently set aside as circulation, could be, that could consist of stairs, corridors, right? That would be blocked out. So this is a type of study that you will do once you have correctly figured out your spatial summary. We will start this in class next, but I'm going to send this to you guys, and hopefully you'll get a head start on it.